Today we are going to use what we've learned about force resolution diagrams and net force equations to solve AP style problems. Make sure that you're not using this video to come up with a procedure to solve all AP force problems because that's not possible. Instead, make sure you're reflecting on the concepts that are being used here. The main concepts that will be used are the idea of equilibrium, another name we give to a situation where forces are balanced, in both x and y directions, and the fact that when we sum our forces, we sum them separately in x and y directions. The first question we go over is also going to help us review what we know about Coulomb's law, or the electric force. If you think back to your first Saturday session, you learned about Coulomb's law then, at the same time that you learned about the universal gravitation law. That's because Coulomb's law looks very much like the equation for the force of gravity between two planets. It's a constant times one charge and the other charge divided by the distance between them. And as you probably remember from middle school or chemistry, opposite charges attract and like charges repel. So in this situation, we have two small spheres with the same mass and the same positive charge, which means they're going to repel, and they're hanging from threads of length L, which means that there's tension in that thread. So the first thing we're going to do is draw a free body diagram. That's what the question is asking us to do when they say draw and label all forces, but just on sphere I, so this one on the right. So as always, with anything with mass on a planet, we have the force of gravity down. Because these are both positive charges, they're repelling, so this ball over here is pushing the ball on the right away from it. So my Coulomb force is here. And tension always acts in the direction of the string. So tension is in that direction. So all set with part A. Next, we're going to draw and label the forces on sphere 1, but this time we're going to resolve them into components. So we're going to draw the force resolution diagram. Remember, the AP test won't ask you to do this. They'll ask you to do the free body diagram. So if you do want to use a force resolution diagram, which I highly suggest to solve problems on the AP test, make sure that they're off to the side so as not to be confused with your free body diagram. So let's start by just redrawing the forces from our free body diagram. And let's set up our coordinate system, reminding ourselves that we want to the right to be positive x and up to be positive y. And so the x component of my tension force is to the left. I'm going to label this FTX. And the y component of my tension force is up. We're going to call this FTY. Remember that components add head to tail. but the resultant, or the vector that we were splitting into components, needs to start in the same place that your two components start and end in the same place your two components end. Our other two forces are already in the x and y direction, but let's draw over them just to remind ourselves that this F Coulomb is in the x direction and this F gravity is in the y direction. So now we're ready to solve the problem that the AP test gives us. And that problem says, find the two net force equations that could be used to solve for charge, Q, so this is my unknown, in terms of ML, theta, and G. And theta, if we go back and look at the diagram again, is the same as what I've labeled in my force resolution diagram with theta in black. So these, in this K, are our knowns. So two net force equations, that's great because that's the next step I would take even if this wasn't the question, means we're going to write our net force equation in the x direction and in the y direction. And even me, after taking years and years of physics, I cannot look at this question and think, oh, I know exactly what equations I'm going to find. Instead, I see that in this situation, I have vectors, I have different directions, and I have forces, and those forces are balanced. So I know that the next step I need to take is writing my net force equations in each direction. And hopefully those will eventually be useful in finding the charge Q. So in my x direction, my sum of forces are the Coulomb force. I'm going to put a little x there to show that it's in the x direction, but the entire Coulomb force is in the x direction. And my tension force, but the x component of my tension force. And the x component of my tension force points left, so I'm going to make that negative. In the y direction, my sum of forces are the y component of my force of tension, and that points up, so that's positive. And the y component of gravity, which happens to be the entire force of gravity, and that points down, so I put a negative there. So now I'm going to replace in these equations what I can using these letters. So I know my sum of forces in the x direction is 0 because this is a equilibrium problem. They're hanging from light threads, they're not moving. So the forces on them must be balanced in both directions. I see F Coulomb in the x direction. That's just the same as the Coulomb force. But now I need to go reference all my equations and figure out what equation I can plug into there. So as we showed before we started this question, this is the equation for the Coulomb force. So we're going to substitute it in. K is my constant. My first charge has a charge of Q and my second charge has a charge of Q over R squared minus FTX is this X component that I drew in my force resolution diagram, and since that's opposite of theta, that's going to be Ft sine theta. And in the y direction, my forces are balanced as well. The y component is adjacent to theta, so that's ft cos theta. And my equation for the force of gravity in the y direction is just the same as the equation for the force of gravity, because all my force is down, is mass times the acceleration of gravity. So now I need to look at these two equations and see if it's actually what I need to answer the question. Are they two equations that can be used to solve for the charge Q? So I do have charge Q. Those are my unknowns. I could rewrite it as Q squared. Theta is one of my knowns. K is one of my knowns. But R is not one of my knowns. So I have to go back to my image and figure out if I can get R in terms of something else. So in Coulomb's law, R is the distance between two charges. And so this is R over 2, and this is R over 2. So I'm going to have to use trigonometry to figure out what R is. And as you can see, R over 2 is opposite of my angle theta. So sine theta equals R over 2 over my length L. So L sine theta equals R over 2. 2L sine theta equals R. And that's what I'm going to plug into my equation. So instead of R squared, I'm going to put 2L sine theta squared. So now, everything in my equation is either a known or unknown except for this force of tension. So let's come back to that. On my y direction side, I have theta, m, and g. Those are all knowns. And I have a force of tension, which is not a known. So now I see I have one equation that I can be used to find Ft. So I would use my net force in the y direction equation to solve for Ft. And then I would plug that Ft into my sum of forces equation in the x direction to algebraically find Q. And the beauty of this new AP test is that they are unlikely to ask you to actually do the math to calculate Q or to get an expression for Q. Instead, they want you to explain how you would do that. And the way you do that is you show how you find this equation and this equation. And you use words like these to explain how you'll use them.